Okay. A rational is a square number.
Okay, so if we have a rational surd, we have something like the square root of
49.
49.
Is 7.
Okay.
And then irrational is not a square number.
Okay.
So to simplify.
So maybe 12.
Okay. Yeah. Okay.
Should we do square root of 12? Yeah, go on.
Okay. So to simplify a surd, you split the radical. Where did radical come? Okay. So the radical is the actual number.
So the radical is the number. Good. So in this case, 49 is the radical.
Yeah, and so is 12.
Yeah. Okay.
And then, okay, so to simplify, so you split the radical into a square factor and another factor. So since 49 is already a square number, you're just going to put them into factors, and that is 7 and 7.
Okay, so we can look at it. So we've got 7 times 7.
And 7 times 7 is 49, of course.
Yeah.
So that would be the little thing is 7 times the little thing 7, a root.
Root 7
and
times.
because they're both 7, they cancel each other out, and you get rid of the roots, and it would just equal 7.
Okay. So just to jump in there, so you would already know the square root of 49 is 7, but actually some of you might jump in there and go, oh, hang on, Pops, it's not just 7, it's
What's
minus 7. We can have 2 possibilities. That, by the way, is we need to include that at some point. So we would actually say that we could have plus and minus 7. But what we're doing at the moment, just with simplifying our surds, because actually we're keeping a surd part, we're going to have an irrational part, we can consider that later. But this was also an important one. If you multiply 2 surds with the same number together, you end up with just that number. Right, that was an important fact. Do you remember doing that a lot?
Yeah.
The root 2 times root 2 is 2 and so on. Okay? So this one split nicely to the same factor. So if you've got that situation, great, but that means you have a square number, which you're going to be able to do anyway. 12, however, is not a square number, so you were saying that we had to find a
2 factors of 12. So I'm just going to
factors of 12.
The easiest one, which is I was going to do 3 and 4.
3 and 4. Why? I'm going to write 4 times 3. Why 4 times 3 and not 2 times 6?
4 is a square number for 2.
Yeah.
6 is not a square number. Neither is 10.
Okay. So we're looking for a square factor.
Oh, never mind.
So we're looking for a square factor. So in this case, we have our square factor. So we can do the same thing again. And we say we've got root 4 minus root 3.
And you notice that 4 is a square number, so you have to do basic. So 2 times 2 is 4.
Yeah, so root 4 is 2.
Oh yeah.
And then the 3 is still 3. Yeah. So we have now a rational part and an irrational part.
And for the first one,
why
is it just 7?
Well, because root 7 times root 7 is 7. You can see it because what is the square root of 49? 7. So if I split the square root of 49 up into root 7 times root 7, it doesn't change the answer, does it?
So you just have to do 49?
Yeah.
Okay.
What Layla was doing is just explaining the method, and we can see, because by breaking it up, it helps us because we are going to get to a point where you multiply 2 things together, and if they're the same, you end up with that number. So it's important to see that fact. Okay.
Also on the test, will we have to write plus?
Oh, don't ask me anything about tests that haven't been written. Or
I mean,
don't.
We have to write plus and minus.
Please, do not ask me anything about tests. Nearer to, if we haven't even got a test. Okay. Ask me a question about this, but do not do in the test. I want to know, do you want to know knowledge rather than...
When we answer stuff, do we have to write plus or minus 7?
You, here,
Like at the top.
you should.
Okay. So is the rational number always a radical?
Say it again, sorry.
Rational number always a radical?
The number inside the root is called the radical. Okay? Yeah?
You know how you did plus or minus 7?
Yeah?
According to my notes, it says that if it's like a negative number,
Yeah?
and that's called a real number, but there is no solution.
Why?
Oh, okay. I'll just come back to that in a second.
I don't understand why negative. Like, why can't it just be positive? You're gonna get the same answer anyway.
So that's how we
Like,
Because,
what's the purpose
for
of it?
instance, it's a good question. Let's say we're going to algebra. So algebraic stuff is just working with numbers. If I said to you, x squared equals 25, I am looking for a number that when I square it, I get 25. Well, is it only 5? So in this case, I would say x would be the square root of 25. Therefore, x can be plus and minus 5. So I'm asking you, what values can x be? X can be 5, but x could also be minus 5. And they are different numbers.
How do you know you're right then?
Both.
You just said you plus or minus equals either positive 5 negative 5.
We have to give both answers. You have to give both.
So you write two.
You would write
numbers.
both answers. When we get into solving quadratics, you have to give 2 solutions.
So you say 5 or negative 5.
Yeah, you just write it.
Sorry, Samira, you had a question?
No.
No? Okay. So this is why surds are important. Now, what we're going to do though, yeah?
Can I see it?
No.
Where are these recordings going?
They're going eventually on Firefly. Could you have a look, please, at page 136? It's exercise 6E.
Oh, I already did that.
Okay, all right, good. Question 4 and question 5. I just want to check that we're all good before we move on to where it gets more difficult. Okay? So I just want to check. If I said to you,
I don't think I need it up before, to be honest.
so if I look at question 4G and I do 3 root 2 minus 5 root 2 minus root 2. Okay, I've just written on the board what question it is. Question 4G. 3 root 2 minus 5 root 2 minus root 2. Gabriella, what would be the simplification of that?
It says 4 root 2
And it's
on the question.
Does it? Okay,
Yeah.
well this one will do.
Okay. It says plus 5 root 2 take away root 2. Is that?
Yeah, I've actually written out J, haven't I? Not G.
I know what it is.
Right,
I think I know.
I'm waiting for us girls at the back. You've got lots of chatting going on. I can use your name and shame if you like.
I don't think it's.
Or I can just ask you for your... Not even... Do you know what you're doing there? Yes, no?
I think I do.
Okay, well, good then. Let me know what the answer is. You got a question or are you going to send it? Okay, let's try to check for people. I'm kind of hoping that this is stuff that you'll know how to do. I'm just trying to mop up the few that maybe haven't quite got there. Have you done it? Do you know? Okay.
It's negative 3 to the
Okay.
square root of 2.
Okay.
I got 2 to the negative 2.
Negative 1 to the power of
Can't do that very wrong.
2 to the negative 1.
Yeah, I got 2 to
So
Isn't that an imaginary 1?
here.
Yeah.
5.
Okay. So basically, to explain, just in case people aren't quite getting it, imagine that, well, root 2 is a number, but I've kind of got 3 of them, 5 of them, 1 of them. So imagine I'm doing 3x's minus 5x's minus 1x. What would you end up with?
-2. -3. Oh.
Yeah, negative 3x. Okay?
How?
Because you've got 3 of them. Take away 5 gives you
-2.
-2. Take away another 1, -3. Remember that from your algebra. So we do the same thing. So this would actually end up being -3 root 2.
But I know this sounds weird, Mr. Pons, but say because there's 3 choosing all in brackets, shouldn't they cancel each other?
Okay, right. It's a good point. What was your question before we go there?
Oh, I was gonna ask if it was 3 root 2 and then take away just, and if we didn't have the last one, the negative.
This one?
Yeah, if we didn't have that, would it?
All right, let me just rewrite. So if we had 3 root 2's minus 5 root 2's.
Yeah. It'd be negative 2.
Look at this.
It would be -2 root 2.
I got it.
Right, now, I was asked a question. Well, doesn't the root 2 and the root 2 just become 2?
Yeah, that's what I thought.
Would anyone have a comment on that? Yay or nay?
I have for both, so one y it should and one y shouldn't.
Okay.
Okay, so y should because they should cancel each other out, but then y shouldn't is because there's 3 of them, and you should only be able, I think you can only cancel out if there's 2.
But would you say, for instance, here that this x gets rid of that x? Why?
Because they're the same, but then you have one left which can't get rid of one by itself. No, I can't go to play.
No, don't, I'm interested. I'm just trying to think about what you're saying. Go on.
But there's 3 times x or 5 times x and 1 times x, and you're not. It's not 5 x. It's not a whole number. I don't know how to.
Yeah, no, I know exactly what you mean. You would right. It's 3 x's, 5 x's, and 1 x. Okay, so I have 3 of them. I think I said, or maybe it was in my IB1 class again, that 3 is not 3. That might confuse you, but does that make sense? It is not 3 in its own right. It's 3 lots of x. So I could rewrite this.
What confuses me is when it goes 3 minus 5 is 2, and if you do minus x, wouldn't that be not 3? That's like adding the final x on instead of taking it away. It's minus.
Oh.
Well, let me try and explain it like this. Okay, if we think of it like...
You can still cancel them out and have one left left.
Right, what I was trying to explain before that little interlude for snacks was 3x doesn't mean a 3 and an x, it means 3 x's. So if I were to write it out like that, it means you have 3 x's and you have to subtract 5 x's. So that leaves you with what? Minus 2 x's. It doesn't leave you with -2 and then the x is gone. Okay? Same way if I subtract another x. Well, if I started with 3 and subtracted 5, then I subtract another one, I am going to end up with -3 x's. Now, that's a bit difficult to represent, isn't it? Because a negative amount of something is quite difficult to represent. But do you understand why it's not the x subtract the x and that goes and you're just left with -2 there? Is that, yeah?
Wait, so because that one wasn't originally there and we put it there, that's why
It gets added on.
No, that's no.
This one?
No, well, we just ignore that one because
No, someone asked.
Why's get added?
Wait, hold on.
Jasmine asked what it would be if we didn't have to subtract the final one. Different question.
Oh, so that's.
This is a different question, right?
Okay.
Different question. So it's like, this is one question, that's the solution. The question was, if you didn't have that one in the question to start with, what would the answer be? Okay. No?
So, since this is simplified, is that the final?
So this this is as simple as it goes because, remember we talked about simplification? It's reducing the number of terms. So we have 3 terms here. After I simplified it, it has 1. So that's our aim, is to simplify it down. Now, it just so happens when you have no x's involved, but it's all numbers, it then is one single value. So, yeah.
What happens when the numbers and the square roots aren't the same?
That's a very good question, actually. Very good question. Can I just ask everyone to consider this? What if you had, let's do 3 root 2 plus 2 root 3 minus root 2? Just have a quick think before I let someone tell me the answer. Have a think. Do you all have a kind of idea in your head? I'm going to ask Naya, so you can kind of put your hands up. She had a hand up. I'm going to ask her, but can you at least have an idea in your head so that if she tells us the answer, you will either agree, disagree, or whatever. Okay. So we have, in this set case, 3 root 2s plus 2 root 3s minus a root 2. Do you all have an idea? What would you say?
It's like collecting like terms. So it would be 2 root 2.
So this is collecting like terms. Same with the algebra, isn't it? So it would be, sorry?
2 root 2
2 root 2s
plus 2 root 3.
plus 2 root 3s. Does that make sense?
Yeah.
So in the same way, just in case, just to give you an option, if it was 3 x's plus 2 y's minus an x.
That's literally what those are the exact letters I have. That's what I learned.
That's what you. It's a way of thinking about it, if you like. So yes, the roots don't just get disappeared, or So it is collecting like terms. That's right. We collect the root 2s. We collect. You can't just add root 2 to root 3. Right. So we should maybe put a note there. Root 2 plus root 3, right, is very different to root 2 times root 3. So root 2 times root 3 would be, any ideas? Not just 6, but root 6. Is there anyone that doesn't get why? Would like to explain? Do you remember we split the radical into factors?
Oh yeah.
It is doing the opposite. So we're doing, well, that is root 2 times 3.
So then if you break them apart.
If you break them apart, it becomes what we do. So it's kind of doing the opposite of what we've been doing. But root 2 plus root 3, root 2 plus root 3. Nothing happens, no change. Okay? So that's quite an important bit. Okay? So that's kind of adding and subtracting. What are you writing that, by the way? Would you like me to slow down?
Wait, is that the answer? Root 2 plus root 3?
Yes, that's the final answer. Right, so we're going to... Any other questions or... No? Yes?
Are you because one of them isn't rational?
Say it again.
Is it because one of them isn't rational? That's why it's hard.
Which one? A or B?
Well,
What do you mean is one... It's just like...
I'm just trying to know why you did that. Or is it
What do you mean? Why I did it or why I can?
why you can't?
It's well, do you remember we've already done this simplification? If we have roots, we said root 49 could be written as root 7 times root 7. Yeah? Happy? Are you happy with that? So it's just the other way round, because the reason why this happens is because we can have root 7 times 7. We are just going backwards. Yeah? But when we're adding, we don't. This is, I guess, a good point to say, well, you never do. So what some people would do is this. So if I were asked to do simplify root 15, they would do this. They would say, oh, well, that is roots, because they're looking for something that they can do as a square number. So they would say, oh, well, that's root 9 plus 6. Okay? Which it is. It is. But this is not root 9 plus root 6. You can't do that. Check it out if you like, using your calculator. It doesn't work.
That wouldn't make sense because that's not timesing them. It's adding them.
Exactly. You can split it like that in the surd, but it doesn't help you. It doesn't. There's nothing. You can't then split them. So it definitely is not equal to 3 plus root 6. Okay. So this is not.
One's a square number. Oh yeah.
This is not possible, because what people think is, we're looking for a square, but the word is factor, and factors are all about multiplication. Yeah?
Wait. Wouldn't that just be 15? Oh, never mind.
So I have said not possible. That bit's fine. It's this bit is not possible.
Oh.
All right, we can't do that. Question?
So that would just be the answer of that.
Yeah. So root 15, unless we can break it up into factors, one being
3 and 5.
Yeah, we could do 3 times 5, but would it help? No. So root 15 would just stay as root 15.
Oh, so some can just be left.
Yeah, if you can't, remember it's all about simplifying. If it can't be simplified, we just leave it as is. Alright. So root 15, we would say, cannot be simplified. Alright, so can I get you then, please, to have a look at questions 4 and 5 yourself and get a few done so that you're happy with those. And maybe if you go back to question 3, if you're happy with the addition and subtraction, do the multiplication. The answers are in the back of the book as well. I can check if you don't know where you've gone wrong, let me know, but you can definitely check your answers in the back of the book.